Imagine for a second that you're standing in the pitch-black darkness of a moonless night. You can't see your own hand in front of your face. Yet, with a simple flick of a switch, the world erupts into a shimmering, high-definition ghost green landscape. Most people assume night vision is just a camera amplifying light, but that's barely scratching the surface of the truth. What you're actually looking at is a vacuum-sealed miracle of quantum physics, capable of capturing a single photon of light and turning it into a river of electrons. And here's what nobody tells you. The process to build just one of these tubes is so delicate that a single speck of dust can render the entire device useless. You might think this is just standard electronics assembly, but you'd be dead wrong. We are talking about a manufacturing process that requires a higher level of precision than building a luxury watch, and a cleaner environment than the operating room of a top-tier hospital. Today, we are pulling back the curtain on the clandestine world of night vision production. From the deepest mines on the planet to the final, high-pressure vacuum sealing, we are going to show you exactly how humans have mastered the art of seeing the invisible, and what happens next in the production line will likely shock you. To build these goggles, it all begins with the Earth itself. The heart of night vision lies in a component called the microchannel plate, or MCP, which relies on a very specific type of lead glass. This glass is sourced primarily from specialized chemical refineries in Germany and the United States, utilizing high-purity silica sand that is processed to 99.999% purity. Think about this. If even one atom of copper or iron makes it into that glass mixture, the entire photon-to-electron conversion process fails at the molecular level. It's an incredible supply chain that stretches across thousands of miles, moving raw materials that are worth more than their weight in gold. But the glass isn't just sitting in a warehouse. It's being refined in high-heat crucibles at temperatures reaching 1,600 degrees Celsius, or nearly 3,000 degrees Fahrenheit. The glass is drawn into millions of tiny, hair-thin fibers, each one thinner than a human red blood cell. These fibers are bundled, fused, and then sliced into discs that form the core of the night vision tube. If the fiber alignment is off by even a single micron, the image you see later will be blurred, distorted, and practically useless. It is a grueling, slow-motion ballet of heat and precision, and the failure rate during this initial phase is enough to make any engineer sweat. Here is a secret most people never think about. That delicate glass disc has to be treated with proprietary chemical coating, an alkali metal film, in a process known as photocathode activation. This has to happen inside a total vacuum chamber. If oxygen touches the surface during this stage, the chemical bond is permanently ruined. The smell in the lab is sharp, clinical, and metallic, and the silence is absolute, broken only by the rhythmic hum of vacuum pumps running at 10,000 revolutions per minute. This is the moment where science fiction becomes reality, and the stakes could not be higher. Now, we transition to the assembly of the body, which is where things get truly extraordinary. We are dealing with aerospace-grade aluminum housings, milled to tolerances of 5 microns. That's less than a tenth of the width of a human hair. These housings are CNC machined in a facility where the temperature is locked at exactly 20 degrees Celsius or 68 degrees Fahrenheit, because even the expansion of the metal from body heat can ruin the fit. You can hear the high-pitched scream of the diamond-tipped bits cutting through the metal at 20,000 revolutions per minute, carving out spaces for optics that must be perfectly centered to catch every stray light particle in the environment. Once the housing is prepped, the optical lenses are inserted. These aren't just glass. They are multi-coated, high-density lenses designed to survive extreme thermal shock. Every lens is inspected under a laser scanning interferometer, a device that maps the surface of the glass for microscopic scratches or imperfections. The rejection rate for the optics alone is nearly 15%. This means for every 100 lenses created, 15 are discarded, melted down, and started over from scratch. It is an incredibly expensive process, but what happens next will change your perspective on what these machines are actually capable of. We reach the final integration, the marriage of the electronic tube and the optical assembly. A robotic arm, controlled by AI-driven sensors, aligns the image intensifier tube with the objective lens. It's an automated process that happens in less than 30 seconds, but the calibration takes hours. The assembly is then nitrogen purged to remove every trace of moisture, ensuring the goggles don't fog up in freezing temperatures or deep jungle humidity. At this point, the device is sealed with an O-ring that is rated for depths of up to 20 meters, or 65 feet, underwater. Most people assume these are just for land, but the durability requirements are insane. Quality control is where the human element finally takes center stage. Machines can check for electronic continuity and light sensitivity, but they can't replicate the nuance of a human eye detecting a shimmer or a spot in the image field. Technicians spend their days in a pitch-black testing bunker, looking at star charts that simulate conditions from bright moonlight down to starlight levels. If a single pixel is bright, a phenomenon called a bright spot defect, the entire tube is pulled. These technicians have eyes like hawks, and they are the final gatekeepers of perfection. Before we talk about the massive scale of this industry, consider this. The global night vision market is currently valued at over $7 billion annually, and it is growing at a breakneck pace. Top producers in the United States, France, and China are currently locked in a technological arms race to miniaturize these devices even further. We are seeing a massive shift toward fused systems, combining thermal imaging with standard night vision. Over the last 50 years, we've gone from heavy, bulky gear that weighed 5 pounds to lightweight helmets that you can wear for a 12-hour patrol. And in the next 10 years, projections suggest we'll see full-color night vision become the standard. Did you know that the ghost green color isn't actually what the device sees, but rather a choice made because the human eye is most sensitive to green wavelengths, which helps reduce eye fatigue during long-term use? Or that a single high-end tube has a life expectancy of over 10,000 hours of continuous operation? And perhaps the most shocking fact of all, the technology inside these goggles is based on a concept called the photoelectric effect, first explained by Albert Einstein, the very same work that won him the Nobel Prize. It is wild to think that a fundamental law of physics is sitting right there, inside the device, working silently every time you flip that switch. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.